This is one of the amazing questions as quoted by one of my students, and she wanted me to solve it. So I'll try to solve it now. The fundamental approach to solve this kind of question is to cube both sides and get an equation which is free from radicals. What free from radical actually means is the next equation should not contain any root kind of terms. So after cubing both sides, this equation turns out to be free from radicals. But the resulting equation this time happens to be a cubic equation. A cubic equation with very large values of coefficients. Although there are processes to solve cubic equation like the quadratic ones, but to solve a cubic equation with this much large values of coefficient just manually by hand would be very difficult for me. So I will first try to get the answer by using computer. I'll use the online version of Sage Math. Sage Math is a collection of already written mathematical programs which we can use at just one declaration. They also provide an online interface where you can write the program in their online cell which would run on their computer and the result will be displayed back to you. So let us open Sage Math in Google. I'll write Sage Math cell. The first result is what we need. I'll use Sage Math cell server. Then this is the cell server. I'll use the language as Python because this is what I'm comfortable with. So I'll now start programming. I'll write x equal to variable x. This is just declaring a variable x. And then in the next line, I'll write the equation. Which reminds me that I have not written the equation in the standard form in the previous slide. So I'll go back there. I'll write the equation in the standard form. So the standard form of equation is x cube plus 3 times of 2025 cube into x square plus 3 times of 2025 to the power 6 plus 1. This plus 1 comes from the right hand side times x plus 2025 to the power 9 minus 2025 equal to 0. So after getting the equation in standard form, we'll go back to the Sage Math cell server again and we'll continue programming. We'll write the equation as 1 times x power 3, this double star means power, plus 3 times of 2025 to the power of 3 times of x square star x double star 2 plus 3 times of 2025 to the power 6 and this whole power, this whole plus 1. This plus 1, the bracket should be used appropriately, otherwise the computer will get confused, times x plus 2025 to the power 9 minus 2025 is equals to, here we'll use double equal to 0 because it's the syntax of computer. Now I'll use the solve function to solve this equation and store the result in the variable called solutions. It's solutions because I know there would be 3 solutions. And then I'll tell the Sage cell to show the solution. I'll use the show function. And now after pressing the button evaluate, we will get 3 solutions in which 2 are imaginary while 1 is real. The real solution is also a negative of very large number which we cannot predict. So what I concluded is there must be some another way in which we can solve this question. It turns out that the solution is very interesting, manipulative as well as short. So let us assume that cube root of x, 2025 minus x happens to be equal to y. So this will gives us that y cube is equals to 2025 minus x, and then we'll say that x equal to 2025 minus y cube. Also it could be seen that x plus 2025 cube would be same as y. This will gives us that x equal to y minus 2025 cube. Now we'll number these equations as 1 and 2 and we'll compare these 1 and 2. Since both are giving us the value of x, both are equal, we'll get 2025 minus y cube would be same as y minus 2025 cube. And clearly it would be visible that by these kind of comparison we'll get y as 2025. Now, after getting the value of y, it is very easy to get the value of x. Either we can use equation 1 or we can use equation 2 or we can do directly from scratch. We'll get the value of x as 2025 minus 2025 cube. which turns out to be the same number what we saw in the real value of the solution by computer. It's -83037636600. Although this approach gives us only one solution, but it nicely depicts how mathematics is a game of manipulation. Although I cannot guarantee that this kind of approach could be generalized to some problem of different pattern. Still, if this question is asked in some competitive examination, it's a nice test of your mathematical manipulative skills.